of thing you can have with our try, van, var, try 0, try 1, supply 1, supply 0, supply 1 are different thing. This is used in switch level modeling, and supply 0 is like ground and supply 1 is like VDD on your MOSFET. So this is power and ground nets, and constant 0 and 1 means if you are using any switch level modeling, it can be used as plus 5 volt or something, but let's say for now 0 and 1. Try 0 and try 1 try state, we mostly don't use this type of data type. For our verification engineer, design engineer use these things. I have given one example for that. So for example, if you are using wire W and you are driving, as I said earlier, we will use with wire or net type of data type. So W is like 1 and W is 0. So if you will conflict that, it will give us X, and we don't want X, we want some value. So we will use wire OR. So this 1 or 0, it will give ORing of this 0 and 1, and ORing of this is 1. So this is like that. And similar, wire end is like, it will give ending value. So if wire end was used here, the value will be 0. So these are some data types and its uses. So next is our variable type data type. So variable will store the data. So rich, see now this is our triggering statement, always at the procedure block, always is our procedure block, at assign was our continuous block, continuous assignment block, we say that. And at every passage of clock means it is a flop, like this kind of thing. And every passage of clock, A equal to B, and this is a non-blocking assignment. I have already made the video for blocking and non-blocking. So this is non-blocking, and A will get the value of B. So this is the some process is going on here, that A will get a value of B at every passage of clock. So every passage of clock means like there is some storing element here. So in reality there will be like one flop which is A and one flop which is B, and A will have some value and this will give it to B, for example 1 1. So this will be storing 1 and B will also storing 1, and after sometimes if A equal to B, then A will give this value to B, then again A will give the value to this B. So it is not driving, it is storing at every passage of clock. So what is happening here, see this is a clock and this is every passage of clock. So this time period for T, it is storing this 1 for this time period of T, is storing this 1 for a time period of T. So for storing this one, this A needs some memory, and this memory is our reg variable. So reg will give some memory for temporarily storing this one, and A will give this to our B. So therefore we need reg, and similar to our net data, we also have some data types for our variable data types. So reg I have already stores a 1-bit value. We can use as a vector or array. It will come next after this day one video. So after that there is integer. So integer is 32-bit variable. You can directly use integer and A, and you can store a 32-bit of value. It is also a posted data type, so it will show like if you are saying 0x011 or x. So this type of number also you can store in our Verilog. Real is our real number, like it is our 0.0. It is a default value of real, and you can store a floating numbers in like that. Time is our storing a time variable. We will see this $time after some time, and this time is called system task, and I will explain this afterwards. So this time will store the time value, like for example 1 nanosecond, so it will store 1 nanosecond or something, and real time will store a real value like 1.1 nanosecond. So this 0.1 nanosecond will only store in real time. Now most important thing is the reg has a storing element. So I will change the color. Okay, one sec. Okay, so